So hello everyone. Yeah, my name is Ricardo Sueiras. I'm a developer advocate at AWS. I've been working with open source for since 1997, so over 20 years. And I've been working with Java probably longer actually. And whilst I don't use Java in my day-to-day life anymore, I certainly owe Java probably a great deal for much of my successes in my early life. I worked with many Java application servers, and also it's one of the reasons why I ended up kind of following my heart with open source. So this talk really is to talk about Amazon Corretto, which is a downstream distribution of OpenJDK, and hopefully to show you that Java is actually still very much alive and kicking and relevant. Before I start, how many people here would say they are actively using Java today? Okay, so a few. Hopefully we can get a few more people using it, because you know, I get it. It's like, it's not cool, is it, anymore? It's not cool. So I'm going to set the scene, because I kind of figured that not everyone would know Java. So I'm going to go way back. And in fact, actually, interestingly, as I was researching this talk, 1985, a great film was released. The clue might be in the title. Any ideas? Back to the Future, 1985. At Sun Microsystems in 1985, they had an idea, and that is they wanted to put code in set-top boxes. It wasn't until 1989, however, that James Gosling, as part of Oak Technologies, that's what Java was originally called, kind of put something together, and eventually it was called Java. And if we look at kind of like some of the metrics around, you know, programmer popularity, programmer love, whilst Java isn't number one, Rust I think is still number one, it is actually still very much popular and used and loved. And actually, so I should actually add, I like to doodle, I like to scribble, so all these are my little concoctions, so apologies for the quality and the readability. So yeah, and this guy here is called Duke. He's the mascot of OpenJDK, not Java. And as I mentioned, for many people back in the day, Java was the gateway to open source. Back in the day, you know, when you wanted to create an application, you might use Hibernate, you might do logging using Log4j, you might use Apache Common libraries to simplify how you do common things. And actually, it was really easy to manage your dependency tree and your dependency graph. It was really easy to do risk and compliance, because you could count the number of open source projects on, you know, at least one person's hands. You know, when JavaScript, you know, came along and NPM, that kind of went out the window. So for many people, you know, we cut our teeth learning how open source worked using Java. So we have a lot to be grateful for in that respect. But this talk really, I wanted to kind of talk about Amazon Corretto, which is a OpenJDK distribution. And to set the scene, I want to talk a little bit about Java and Amazon. So we are very big users of Java. 80% of all the stuff at Amazon that's written is Java. We're increasingly using Rust a lot as well. We've got lots of other things as well. But if you think about kind of like the services that you might use if you're using AWS, like Lambda, like Elasticsearch, well not Elasticsearch, OpenSearch, Amazon EMR, Redis, and a few others, they're all written in Java, but the actual control plane in Amazon, in AWS, is written in Java as well. So every time you invoke a Lambda function, it goes through a whole bunch of Java control plane admin fronts before you actually get executed your code. And what's interesting is that you know, our kind of growth of Java over that time has actually meant that we get to see things that no one else sees. You know, when you're I mean, Java Lambda functions are invoked trillions of times a day, and when you're running Java at that scale, you get to see bugs. And you see bottlenecks that aren't there. And so we have teams of people that are focused on identifying and helping fix these problems. Now, with open source, you have two choices. You can fix those yourself. You can fork the project. You can fix them, and then you're happy. The problem when you do this with Java, with any project, not just this one, is you have this thing called a forking tax. So you start to kind of create two divergent paths. And then as the community builds new features, you've got to figure out then how to move them across. And it's actually really, really hard to do. It takes up a lot of engineering cycles, and so it's really a bad idea. And so a lot of the effort we had was making sure that a lot of those fixes were fed back upstream so that everyone could benefit. Okay, so that's kind of like one of the things that we saw. And it kind of led to kind of three kind of key areas of focus for us. The first was around security. Amazon, security is our top priority. So one of the things that we wanted to make sure is that as we started using Java and we started getting CVEs, we had engineers that would actually fix those and then submit those quickly. However, one of the problems we had was typically there's a lag between a CVE being recorded, a patch being created, and then that patch being made available. And when your priority is security, we needed to figure out how we could actually reduce the time from CVE to deploying on production. And we'll come to a second as to how we fix that. The second thing is that when you're running at scale, like small margins make big differences. And they can make the difference between having to scale up thousands of servers versus hundreds of servers. So there's an economic impact of doing that. So making sure that we can optimize and make performant Java was also a key priority. And then the final one is no one likes to access their systems if they're not up. So making them robust and making them robust at scale was also really important. Now this is in the context of how OpenJDK kind of evolves, and this is like the roadmap. Actually, I should start because not everyone here is familiar with Java. Java is two things. It's a programming language, but it's also a runtime on which you deploy your applications. Now you can develop in Java, or you can develop in some more modern Java-like applications like Kotlin, Scala, and they can compile and they run on the Java runtime. So you can actually run on multiple different languages, but you still run those on a JVM, such as OpenJDK. When Java was originally created by Sun Microsystems and then bought by Oracle, it was closed, it was proprietary. It wasn't until OpenJDK came along that we had our first open source way of running your Java applications. And so the way it works, the roadmap is that we have releases. So these are different versions. So you can see 7, 8, 9, etc. And we have these kind of longer lines that go here. And these are what's called long-term support. So anyone who's familiar with Ubuntu or other Linux distributions are familiar with that. You have point releases that have new features. They're typically battle tested there, and they get rolled up into long-term support. And this is really important because if you are running Java in your environment, you want to make sure that you have long-time support. But typically you want to use the features in some of these because they're going to provide new security features, better performance, more stability. So the trick is, how do you actually manage that tension? Around 2018, Oracle, who up until then was providing support for Java, decided to change and remove free support. And that was causing problems, not just for us, but also for our customers. So it meant that we started to build. And we started to build our own Java distribution. It's called Ristretto, which is a type of coffee. And the way that you typically build, anyone can take the source code of OpenJDK and you can compile it and you have your own. Now I could call it Ricardo's OpenJDK distribution. And typically what you have to do is you have to put your compiled source code through these things called TCK tests. They're compatibility tests that confirm and give a stamp that this will run Java applications properly. And so there's a whole bunch of steps that you have to do. And so we decided that the best way for us to reduce the time it takes to get new features, to quickly apply patches was to start building our own distribution. And we did that internally. The culture and how we structure teams within Amazon is we have very small teams. We have lots of them. We have tens of thousands of these things called two-pizza teams. And they are all completely independent. There are no standards as such. The only mandate, the only contract you have is the API with which your service kind of speaks to the outside world. And so what happened was that as we started producing this distribution, and this was closed internally, the team started adopting this distribution, but they started adopting it kind of like on a kind of pull basis when they needed it. So we weren't really getting a lot of teams doing it. So we needed to do some work. And so we kicked off the great migration to Corretto. And in fact, actually what we did is we created a migration from OpenJDK 8 to OpenJDK 11. And this was really important for us because we wanted to make sure that we were giving these teams the benefits of some of the kind of features, new features which were available in OpenJDK 11. Sorry, excuse me. Now, in the process of doing that, we learned lots of valuable lessons. So we learned, for example, that there were some major performance benefits of using OpenJDK 11. We found that there were issues that you needed to tackle, such as dependency. So libraries that weren't available in 11, between 8 and 11 disappeared. So JAXB, if you were using JAXB, which is a very popular library, that was no longer available in 11. We found, though, most importantly, because we automate all our builds and we have test suites, a lot of the tests were breaking. So we had to refactor a lot of our tests to make sure they would work with OpenJDK 11. But what happened was that when we did that, at a business level, we found massive benefits. So we had lower latency, we had a higher throughput, we had less memory usage. And when you're running at scale, so this is, so actually no, that's not quite there yet. So if you're running here, for example, the latency overhead of Lambda functions, we could reduce the responsive times for Lambda functions by 40% just by upgrading to JDK 11. So as a business, that's a big win for our customers. And so what we did was we started to share this with our internal developers to try and get more of our teams to use and upgrade to JDK 11. Now, we also introduced new features which we open sourced upstream, and so they weren't specific to our OpenJDK. You can run them anywhere, even on Oracle's JDK. A thing called the Amazon Corretto cryptographic provider. And this was an optimization for encryption. And we can see on the left of the graph when it's not being used versus the right when it is. And so this is actually used in snowball devices. Snowball devices are these kind of like, they look like suitcases, and you have compute and storage on them, and everything is encrypted, because the last thing you want is if this gets into a bad actor, that data can get compromised. So encryption is key to this. Reducing the latency and increasing the throughput is important, and we were able to have significant benefits by using this kind of new project that we upstreamed. And then we finally launched in 2018 Amazon Corretto to the general public. And if you want to read more, if you want to know more about it, I actually wrote an article in a magazine that talks about the whole story in a lot more detail. But effectively, what we launched was a OpenJDK distribution with full free support across multiple different versions and different platforms as well. So x86, ARM, 32-bit, 64, Mac, Windows, Linux, that kind of thing. The ACCP, the cryptographic provider, was actually something that a lot in the early days of Corretto was used by a lot of customers to drastically reduce their kind of web farms. So Netflix, for example, they do a lot of Redis and Cassandra. A lot of that is encrypted. They were able to drastically reduce the scale of their fleets just by switching and turning on to ACCP versus standard JCE in Java. So JCE is how Java does encryption at an application level. Now, this is all good, but launching a new open source, an open JDK when there's others, means that you need to learn how to play with the broader community. And so one of the core tenets of the team that created the Amazon Corretto was to make sure that we upstreamed everything. So we don't write something first internally and then release it upstream. We work upstream and wait for those changes to come down. And so in a few years, we've actually become like in the top sort of 3 or 4 contributors to the Open JDK project. And those kind of contributions cover not just code. So one key thing to talk about is that contributions are more than code. They are, finding bugs, writing documentation, peer reviewing commits. All these kind of things make up contributions, and we have a big team that does that. And over the kind of like the versions, we've done more and more commits, and the team is growing, and we're doing more of these contributions. So that's kind of like where we kind of are have been. But what's interesting is actually where the future part of this talk is actually where Amazon Corretto and OpenJDK are going, and what we specifically are doing and what we are specifically contributing to are kind of a number of areas, and I'm going to talk a few of them. The first is Graviton. So Graviton is AWS's custom ARM chip. So we license them from ARM. They're Neoverse N1s, and effectively they allow you to run ARM-based workloads in the cloud. Why would you do that? I can hear you all shouting. Well, they typically are 60% lower energy usage, and they're typically 40% better price performance. So effectively, they allow you to, with very little effort, to run your applications with lower carbon footprint, cheaper. So who doesn't want that, right? It's a no-brainer. And so we created these chips. We've been running them since 2018. And so we spent a significant amount of time optimizing OpenJDK to run well on ARM chips, both 32 and 64-bit. So it means that you can actually now have choice. If you're a Java developer, you can run your applications now on x86 or on ARM. Lilliput is a kind of new project that allows you to optimize the size of your Java applications. And so, again, in order to make your Java applications more efficient, we're putting a lot of work there, because running at scale, this is a big deal for us. And then the final one, which for anyone who has been using Java for many, many years, managing your heap is always the biggest pain. With recent versions of OpenJDK and Java, we've had different options, different types of garbage collector. So we've had the parallel garbage collector, we've had the G1 garbage collector, and we are working with Red Hat on the Shenandoah. And what these are optimized for is allowing you to run Java applications so that garbage collection runs concurrently without any pause time. So for those people who aren't familiar and haven't gone through this in their life, it's one of the big problems you used to have with Java applications, which used to happen to, and you typically would see if you're doing load testing, would be you run your application at load, and then within the JVM, which is where your application runs, you would run out of memory. Now, Java manages memory for you, and it has this thing called a garbage collector, which squishes all that memory, gets rid of unused objects, maybe dead sessions, that kind of thing, and then allows you to carry on. But that process typically stops the application running, and it's called the pause time. And so what would happen is you'd be running your application, and then the application would appear unresponsive until that finished. So it's always been a problem, and a lot of work in Java land was tuning and tweaking the JVM parameters for garbage collection so that you would have less of an impact. And so a lot of the innovations in OpenJDK have been around how to minimize that impact. And parallel garbage collection allows you to have some benefits where they focus on throughput. G1 focused on latency, and Shenandoah also focuses on latency, because for us that's a big deal at Amazon. If we want to try and reduce the latency of our applications because customers care about that. And so we are putting more and more effort. And I've got some graphs to show you kind of what this kind of looks like. So again, pause time of a typical application. So we've got milliseconds on there. And we can see here that we've got these blue lines here are pause times. It doesn't look too bad, right? But we've got these big spikes, and those big spikes are where customers are seeing basically no response. And that's a big problem for us at Amazon. So what we did is when we upgraded to the Shenandoah, what we were able to do is reduce that latency, but we've still got spikes. You can see here that when we turn Shenandoah on, we have reduced further down the latency response to our applications. And we can zoom in to see that. So effectively what we're doing is we're improving the performance of our applications just by using and switching to the garbage collector. One of the other things we did was in iterations of the Shenandoah, we were able to tweak some of the characteristics it was looking for to further reduce the P99 response time. So effectively what this means is that the work we're doing upstream with the project allows us to create an environment where you can run your applications and have very few problems running them at low latency. Something really which has always been something problematic as you ran at scale. And now with working with Red Hat and SAP, we're getting into a much better situation. So, I think from the point of view of people used to be scared of Java and writing Java applications and deploying them for these kind of reasons. We've also, going back to the Graviton, we've got customers now that are migrating their entire business to running Java from x86 onto Graviton. And we can see here, anyone who's using Honeycomb, their observability platform, they blog quite a lot about this, saying that they've had to do very little work in order to do that. It literally, the same application just ran. They just switched instance type on AWS from x86 to ARM, because the OpenJDK team behind under the covers has done all the heavy lifting for them. And we can see what this looks like here is that effectively once you've switched to that, we've optimized the process, the garbage collection on ARM so that everyone can benefit. So some of the kind of key takeaways from kind of like Amazon Corretto and Java today is that for those people who maybe didn't know what Amazon Corretto is, it is a downstream distribution of OpenJDK. There are others. So Oracle do one, Adopt, Aspect Adopt. I can't remember. I always get the name wrong. There's Eclipse, Azul. There's a whole bunch. You can choose a whole bunch of these, right? This is just our version, and one of the reasons why our customers love it is because if you've got an environment, you typically only want one version of your OpenJDK to manage, and this runs on your desktop, on your laptop, on your servers, on-prem, even in other clouds, okay? And you can run the same JDK the same. And that is something that customers really value with support. The second thing is what we found is as customers are moving to OpenJDK 17, typically there is some work to do, but it's nearly always worth migrating because you typically get between 30 and 40% better performance improvements without doing any work. So migrating or looking at how you build a path to OpenJDK 17 is something that you should think about. And then the final one is that as we think about cloud native, Amazon were doing a lot of work around how to ensure that Java works really well on modern cloud native architecture. So whether it's containers or serverless, you can run Java applications with very little cold start problems. So if you want to do serverless Java, it's just as good as running it yourself. And so really there's never been a better time to actually kind of like go to Java. If you want to get more info, or if you want to try it for yourself, okay, one of the key motivations for us creating Amazon Corretto was that, and one of the key things that customers asked us was, we don't want to actually notice the change. So we call this thing a drop-in replacement. So I can be running a version of OpenJDK. I can then switch to Amazon Corretto and you will not notice. So I sometimes do a demo. I run Pet Clinic, which is a very famous Java reference application. We run it on an Oracle JDK, and then I shut the application down, change it to Corretto, and it starts up again and it just runs the same. And that's one of the key things that you want from any OpenJDK, to be able to run as is. And so with that, I think I'm within 20 minutes. Any questions? Also, if you want a copy of the slides, there's a QR code. You can go for it.
Excellent. Round of applause for Ricardo. And again, I know there's a question, but I will also play the co-host card quickly. So I think one of the reasons that Java's perhaps declined a little bit in popularity is because of some of the licensing sort of issues around, and the cost perhaps. Does this help in any way with some of the sort of Oracle Java license costs in any way?
So there's two different things there. Right? So the cost thing. So typically, if you wanted to use Java, there was always this unknown around how you get support for the runtime. So OpenJDK has always published this roadmap. But even still, if you wanted to, as a customer, get support from someone, Oracle would offer you support, and they changed it from being free to being paid for. And Amazon isn't the only company that offers support for OpenJDK, but we do provide it for free. We don't even ask that you're using AWS. You can just use it. And there's 2 channels. So if you use it, you can you can do a problem on Stack Overflow. And we have engineers that look at Stack Overflow, and they will respond. Or if you're a customer, you can do and use the support channel and get support. And then it's like private, and you get kind of like, escalations and that. But you can upstream, and we can do patches and that kind of thing. So yeah, so we don't. So and I know that there are other, like Eclipse and Azure and Adopt Open. They also provide support, but they have. I'm not familiar with what their costing model is. From a licensing perspective, ever since OpenJDK is GPL, I think. With a link provision, a link patent provision. I'm not sure it's a big problem in the same way that Linux development is GPL as well. So I think most organizations tend to be okay because other companies are already creating their own distributions. But it is a valid OSI license. The only thing I've seen where there's been some, I guess, ambiguity is with Graal. So Graal VM is a really cool technology from Oracle Labs that allows you to run Java applications and compile them in a slightly different way so that it works really well in cloud-native architectures. But they're a bit ambiguous in their licensing terms. So that's the only thing I've seen. We've reviewed it and we're okay with it. But again, I'm not a lawyer, so you need to make sure that you check with your own legal departments as to whether you're comfortable with it.
Thank you very much. Thank you very much for the presentation. I have a very quick question. Like, what about the web server, Java web server? So you have also inbuilt some type of the web server, like the JBoss, Tomcat, or WebLogic, or?
So we don't provide one other than if you're using. We have a service called Beanstalk, and Beanstalk was like a version of like a platform as a service. And so with Beanstalk, you can actually package up your WAR file and then deploy it through a standard set of steps. I've not used it that much. So that's the only one that I'm familiar with. We don't provide like a managed application server for Java, at least that I'm aware of. No, we don't. But you can, what we work with open source partners, so, Red Hat, IBM. So I cut my teeth on WebSphere and WebLogic. You can get those via the marketplace. They're AMIs. AMIs are the kind of the virtual machine images. You can literally go to the marketplace, find your favorite preferred. So I use Tomcat, that's my favorite one. I can go there, Bitnami do them, and I can deploy in seconds an Apache Tomcat server, but I will have to pay a slight premium on the instance price, so per second price, because it's Bitnami's image. They maintain it, they patch it, and all that kind of stuff. So if you want the easiest way, if you want something like that, is to go to the marketplace.
And which web server AWS is using? WebLogic, WebSphere?
What are we using?
Yeah.
So we have used Tomcat. So S3, for example, in the early days, S3 was using Tomcat. And interestingly enough, when you're running at that scale, we actually found problems with OpenJDK, was it 7? I think it was 8, with corrupted GStream zip files. with Tomcat. So again, that's one of the fixes we were able to see that no one else was seeing, and we upstreamed the patch. We also used to, with Tomcat, we saw C3 crashes, again, because of the scale we were running at. So I know we're running Tomcat. We're also running Netty in some places, but those are the only two that I'm aware of. But I don't know whether they're still using them or whether we have something else.
And one last question. And how actually you upgrade from one version to the another version in the Java and with AWS?
That's a very good question. So the upgrading process is a talk in itself, actually. So I have actually done the talk. I did the talk a couple of years ago, but it's, in a sense, because we automate our deployment pipeline, and we've got unit tests for everything. What we do is we do standard kind of canary deployments, and the way we do we do this thing called pessimistic deployments. So we will deploy through our pipeline to a single local instance. We'll do our tests. If it passes those tests, and it's a combination of automated tests with some AI and some people, it then gets to the next level. Okay, but any ambiguities in the results means that deployment's failed, and it gets rejected. The next step is to deploy into one rack in one AZ and deploy, and then funnel some of the traffic. What we do is we have a number of customers that have got test accounts, and we have them as well. And so through the canary deployments, we just funnel those tests to make sure that there's no real data going through them yet. Once that passes, we then get the next stage, which is the more racks in that one. And so we do this like 7 or 8 times, ever growing the scope of where we deploy that change. And then once we haven't had any issues, because we're monitoring the traffic, and that actually gets back into the pipeline, any anomalies, any failures, the change gets rejected, the change gets reverted back. But if it all goes okay, then we start moving production workloads as well. So that's kind of like very quickly how it works. But we can only do that because we've got the deployments automated and the tests written for each of us. And every team at Amazon is responsible for their own pipeline. So we have literally tens of thousands of these things, and they're very small in scope, right? Because we have a microservices kind of architecture. So typically the scope of this change, the blast radius is quite small.
It is very similar like the blue and green. There is no major difference.
Yeah.
Okay, thank you. Thank you very much.
That's all right.
Any other questions?
I'll hold the fake mic. So one thing we see with developers is, lots of people coming through, they're excited to buy things like Kotlin, Scala, etc., ways to simplify application development. Every Java talk I've been to with people like yourself, I'm always amazed at the kind of performance enhancements you can get by really understanding what you're running on and kind of the small changes you can make that really make a big difference. Any recommendations on how to sheep dip, excited application developers in that ethos and mentality? Is it a...
Yeah, that's an interesting one. I mean, so some of those performance enhancements, actually, you don't have to think about. They're no-brainers, right? So the obvious one, I hope that most of you have taken away, is that simply upgrading to the latest, newest version of OpenJDK will give you significant benefits. Typically performance, lower latency, higher throughput. And so that's kind of the best case scenario, right? And what's interesting with the Shenandoah one, the Shenandoah garbage collector is potentially very good for some people, but it's not good for everyone. And so what you have to know is actually, how do you know whether your workload is going to be or going to run well in that particular configuration? So we've created some open source tools. One's called Heapothesis. I can never say it. And it's a tool that allows you to simulate, based on your workload characteristics and the environment you want to set. It generates effectively a simulated graph that allows your developers to then see, well, based on this configuration, my application is suitable or not suitable. Or if I tune the parameters, then I'm going to have my optimum latencies. So by providing developers some tools like that, we can help them. But with regards to kind of like the languages, I mean, we have some parts of Amazon that are very big on Kotlin. So if you're using Alexa and Prime Video, they're all Kotlin, right? And specifically why they're Kotlin is because they like the developer experience. It's very easy to write applications in these languages, and they get the benefit of being able to deploy on a well-proven, sort of stable environment. But we don't really, because Amazon, we don't really have these kind of like enforced standards, right? Every team does what they want, and that's why we have Kotlin, Scala, even JRuby. We have JRuby as well, right? As well as Java. So we don't mandate standards. All we mandate is that you, as a team, own that standard, and you are on the hook for it. So we push that down, and so one of the kind of the side effects of this is we have kind of a strong engineering sharing culture, whereby once a week we'll have these podcasts, these videos where engineers from one of the teams will say, I've done this with X. This is what I've learnt. This was what was not so good. This is the lesson you can learn to try and help disseminate things like that. So I'm not sure if I've answered your question, but I hope I've given you some pointers.
Yeah, I've got a quick question for you. You mentioned the use of Java with serverless, and you're reducing cold start times. I'm guessing making Java more a viable option for serverless.
Yeah, totally.
I was just wondering, you talked a lot about garbage collection. With serverless functions typically having a lifespan of milliseconds to a few seconds, is garbage collection an issue, or do you just spin up a VM, pollute the whole heap, and then tear the whole thing down again?
So if you're creating Lambda functions, so for people who aren't familiar with Lambda functions, they're short pieces of code that typically run from seconds to up to 15 minutes, I think. And you're right, garbage collection isn't really an option or really an issue for those. However, cold starts is. And so this is where we're doing work with Graal to optimize the images so that the actual time it takes to actually get from invocation to your Java is reduced. So that's less on the back end. The back end, the stuff that runs Lambda, those processes and those threads are long-lived, and that's where the Shenandoah GC is actually being used today to reduce latencies of the actual control plane of Lambda. So they're two kind of separate things. But you're right. For 15 minutes, you probably don't care about GC because you're not gonna reuse objects, right?
Cool. Can I ask another really important question? It seems like for years I've been pronouncing it wrong. I thought it was Kotlin, not Kotlin. So the important question is it Kubernetes or Kubernetes?
It's Kate's, isn't it? Isn't it Kate's?
Yeah, nicely done.
Yeah.
All right, has anyone got any final questions? Brilliant.
Thank you
Well,
very
it's been a great talk. Thanks for both the speakers and everyone's involvement. Thank you.